This is Year 8 Circles Revision, question 21. In this question, we're asked to calculate the perimeter of this quadrant. So a quadrant is a quarter of a circle, and we need to find the perimeter, which is the distance all around the outside of the circle. So we've really got to look for which bits are curved and the straight bit. So we can see that we've got this curved bit there. So I'm just going to draw that over here. So it's made up, our shape is made up of a curved bit, and it's also made up of two straight line bits. So I'm just going to put those over here. Okay, so we need to work out the length of this curved bit and the lengths of these straight line bits. Okay, now the curved bit is a part of a circle. So remember, when we're trying to work out part of a circle, we should always do the full circle first. So I'm just going to draw a full circle over here, and we're asked to find the perimeter of that quadrant. So we need the distance around there. So we should find first the distance around the full circle. Now that distance, walking around the full circle, that's the circumference. Now we have two formulas for circumference of a circle. We have circumference is pi d, or circumference equals 2 pi r. Now if I just put this circle on top of the other one, you can see that you've actually been given, you have to see whether you've been given the radius or if you've been given the diameter. We can see that we've been given the distance from the center of the circle to the outside, so we've been given that the radius is 3 centimeters. So when we decide which of our formulas we're going to use, we need to use the formula that uses the radius, because we've got the radius, not the diameter. So we're going to use the formula circumference equals 2 pi r. So I'll just highlight that. Okay, so we're going to find the circumference of this full circle using c equals 2 pi r. So I'm just going to do that over here. So for my full circle, I've got circumference equals 2 pi r. Now I'm just going to move all this up a little bit. And my full circle and circumference is 2 pi r. But notice with my shape, I don't have a full circle. What I've got really is just a quarter circle. So I'm just going to bring the working out for that down here. So if my full circle is circumference equals 2 pi r, and I go 2 times pi times r, which is 2 times pi times 3, when I enter that on my calculator, I get 18.84955. Now don't round that off at the moment. Remember, you're trying to work out the quarter of the circle, so you get this answer. So the circumference of your quarter circle is 18.84955, and you have to divide it by 4. And the answer, when you divide by 4, is 4.71238. And I'll just stop with the decimal places there. So we've worked out this little bit of a curved bit here. We still have to work out these straight line bits. So I'm just going to move them down here now. So these two straight line bits we can see are there and there. So those straight line bits are 3 plus 3, which is 6. So I'll just write that down now. So the two straight line bits there are there. They're 3 centimeters plus 3 centimeters, which equals 6 centimeters. So now we can work out the perimeter of the total shape. And so over here I'm just doing the perimeter of the total shape, and it is the quarter circle bit over here, which is 4.7128, plus the two straight line bits, which add up to 6, and so the perimeter is 4.71238 plus 6, which is 10.71238. I'm just going to round that to one decimal place this time. So I'll look at that second decimal place, which is a 1, and that 1 is less than 5, so we can just keep it as 10.7 as the number in front of that one. Okay. Okay, now for question 22. In this question, we're asked to find the perimeter of this figure. Now the perimeter of the figure is the outside. We need the distance all around the outside of the figure. So we've got this curved bit, and we've got these two straight line bits. Now we can see that we've actually got 3/4 of this circle because 1/4 has been removed. So our shape, the perimeter, is made up of, and I'm just going to draw them here. We need to work out the curved bit, which we've got there. And we've also got these two straight line bits, which I'll just draw here. I mean, mine aren't drawn exactly the same way, but we get the idea. Okay, so we've got the curved bit, which is 3/4 of a circle, and the 2 straight line bits. So because we're working with a circle, we need the distance around the circle, remembering that is the same as circumference of a circle. So we'll just write down the formula for circumference of a circle first, and we'll work out the circumference of a full circle as well. So the first thing we want to do to work out the distance around this 3/4 circle, we'll work with our full circle first. Now remember, circumference of a circle, we have 2 choices of formula. Circumference equals pi d or circumference equals 2 pi r. Now if we look at the circle we've been given up here and look at these lengths, we've actually been given r, the radius, so we're going to use the second formula, circumference equals 2 pi r. So we can see that in this question that our radius r is 4. So we're going to use the formula circumference. We're doing a full circle. And we're saying circumference is 2 pi r, which is 2 times pi times 4. And we work that out, we get 25.1327. Now just remembering that we don't want a full circle, we need 3/4 of a circle. So I'm just going to put that 3/4 down here. And to work out 3/4 of the length of that whole circle, our working out will be 3/4 of 25.1327. So I'll just put that down here. So 3/4 of a circle, the circumference is 3/4 times 25.1327, which is 18.8495. So we've worked out that curved bit. Now we just need the 2 straight line bits, and I'll just put them there. Now we can see that those 2 straight line bits are 4 plus 4, which means the total of the straight line bits is 8. So now we've worked out all the bits that we need to do, and so therefore the perimeter of the shape is just adding up all of these things together. So we add up the curved bit, which is the 18.84, and we add on the straight line bits, which are 8. We get 26.8495. Now we're supposed to write this to 2 decimal places. So we want 26.8, is it going to be 84 or is it going to be 85? So to work out what the second decimal place is, we need to look at the third decimal place, which is a 9. Now that 9 is a lot bigger than 5, so it needs to be 5 or more, and it is 5 or more. So we're going to round the number in front of it up to a 5. So our answer to 2 decimal places is 26.85 centimetres. Okay, this is question 23. In this question we're asked to find the area of this figure. Now this is what we call a composite figure. It's made up of different shapes. We've got half a circle here and we've got half a circle there. Now if we put those 2 half circles together, what we've really got is a full circle. So I'm just going to bring in a full circle here. So this shape is made up of 2 semicircles, one up there, one down there. When I join them together, I get a full circle. And the shape is also made up of a rectangle. Now, what I'm going to do, we're going to write the dimensions, which are the measurements of these shapes, on those shapes. I'll just move them down here because I've got a little bit more room. So on the circle, what I've got is this measurement across here, right across there. So I've got that measurement across there, which in this case is the diameter of the circle. So I'm going to write that the diameter D is 5 centimeters. Okay. On this rectangle, okay, because the shape is made up of the 2 semicircles which are put together there and the rectangle. On the rectangle, I can see that I've got this length across the top, which is 5 centimeters. Now that's also the same as that length down the bottom. I've got this other length here, which is 6 centimeters. So what I can do now is work out the area of this whole figure. I need to therefore work out the area of the circle, which I've got there, and the area of the rectangle. Okay, now when we work out the area of a circle, the formula is area equals pi r squared. But we look at the information we've got up here, we don't have r, we've got d. So if d is 5 centimeters, that's the distance all the way across. The radius, which is half the distance, will be half of 5, which is 2.5 centimeters. So we should just write that out first, that the diameter is 5 centimeters, so the radius is 2.5 centimeters. The reason we need to work out what the radius is because the formula for a circle a full circle is area equals pi r squared. So that's why we needed to know what r was, not what d is. So we're going to start off by working out the area of the full circle, which is area equals pi r squared. So I'm just going to bring that in now. So area equals pi r squared, which is, I've got it written twice, it's pi times 2.5 squared. And when you do that on your calculator, you get 19.63495. So we've worked out the area of that circle. Now we just need to work out the area of the rectangle, and to find the area of a rectangle, it's just one side length times the other one. So it'll be 5 times 6, which is 30. So we've worked out the area of the circle, and we've worked out the area of the rectangle, and they're the two different areas that we have to work out. So now we can work out the total area. So we say total area is 19.63495, that one, plus the 30 from the rectangle equals 49.63495. Now we can see all the answers here are to 2 decimal places, so we need to look at the third decimal place, okay? So 6, 3, that's second decimal place. The 4 is the third decimal place. Now that 4 is less than 5, so that means that the 3 in front of it just stays the same. We don't round up. Okay, in question 24, you're asked to find the area of the shaded region. Now we need to see what the shaded region is made up of. Now if we have a full circle, then it will all be shaded. But if I cut out a part, if I cut out the middle of the circle, then I end up with that shaded ring around the outside. So to work out just the shaded bit, what I really need to do is work out the area of the big circle and then cut out or take away the area of the small circle inside it. So we're just going to set up our working out like that. So what I've got here, I'm going to do shaded area equals, I'm just going to draw the big circle, and we're saying shaded area is the big circle, take away the smaller circle. Okay, so if I do big circle and if I take away the smaller circle, I will end up with that ring, just the shaded ring. So I'm just going to put the measurements on the big circle and the small circle. We can see that the big circle has a radius of 8 and the small circle has a radius of 5. So big circle, radius of 8, small circle has a radius of 5 centimeters. Okay, so what we'll do now, I need to work out the area of each of those circles, and I'm going to subtract the smaller circle away from the larger circle. So to do the area of a circle, the formula for area of a circle is area equals pi r squared. So I'll just put that underneath the large circle. So area is pi r squared, which is pi times 8 squared. If you do that on the calculator, you get 201.0619. Now I'm just going to do the same for the smaller circle. So area of the smaller circle is area equals pi r squared, which is pi times 5 squared, which is 78.5398. And just remembering that the shaded area is the big circle, take away the small circle. So I've just moved that around a bit. So our shaded area, just finishing off, so our shaded area is the big circle, area of the big circle minus the area of the small circle, which is 201.0619 minus 78. So I've just put the wrong number there. I'll just fix it up. So once again, 201.0619 minus 78.5398 gives us a shaded area of 155.5221. Rounding that to 2 decimal places, we just look at the third decimal place, which I've highlighted in yellow. That number highlighted in yellow is less than 5, so the number in front, which is the 2, remains the same. So the shaded area is 122.52 centimeters squared, which is answer C. That's the end of this video. The next video will start on question 25.